Hello students, in the previous class we had learned about the type 1 of L'Hospital rule, that is of the form 0 by 0 form. Today we are learning the type 2 evaluation of limits of the form infinity by infinity. Your type 2 is infinity by infinity form, as it is the same, it has the same rules of the type 1 of L'Hospital rule. If f of x and g of x be the two functions given such that if when you apply the limit for the given f of x function and if you are getting the limit as in after answer as infinity, and when you apply the limit for the given function g of x and if you get the answer as infinity, then f of x by g of x is said to assume the indeterminate form, that is infinity by infinity form at x equals a. So here when you get the indeterminate form infinity by infinity form, first what do you do is first you apply the limit for the given function and you get the infinity by infinity form, then you differentiate the given function f of x and g of x separately, then you apply the limit. After applying the limit, if you get the finite value, then your problem will be solved. So one more note you have here, in most of the problems of the form infinity by infinity, it is necessary to change it into the 0 by 0 form at the proper stage, otherwise the process will never end. So what this note means is that when your problem is given limit x tends to f of x by g of x and you are getting the infinity by infinity form, in not all the problems, in few of the problems it is necessary to change the infinity by infinity form into 0 by 0 form at proper stage, not at every stage, at proper stage, otherwise the process will never end. Even on this note problem, let us solve a problem on this note point. So first, what is your first problem? Your first problem is limit x tends to 0 log sin x by cot x. What is your first step? You have to substitute the given limit, that is x tends to 0, in the numerator and denominator. So what it will be? Limit log sin 0 by cot 0. As you all know, sin 0 is 0, cot 0 as it is. So log infinity, since the value of log 0 is minus infinity. Remember, the value of log 0 is minus infinity. The numerator becomes minus infinity. Denominator cot 0 value is infinity. So let us first write the given problem. Limit x tends to 0 log sin x by cot x. So here log sin, let's write the given problem. Limit x tends to 0 log sin x by cot x, and we say that it is in the form of minus infinity by infinity. Minus infinity by infinity and infinity by infinity are the one and the same. So what does the rule 1 says? Carry the limit x tends to 0 as it is. Differentiate the numerator and denominator separately. So what is your differentiation of numerator? Log sin x is 1 by sin x. Sin x differentiation is cos x divided by cot x differentiation is minus cosecant square x. And here the given here numerator f of x, that is can be written as cos x by sin x is cot x and minus cosecant square x. After differentiating numerator and denominator separately, you have to apply the limit, right? What is your limit? When you apply the limit here, what do you get? Cot 0 by minus cosecant square 0. Cot 0 is infinity divided by cosecant square is differentiation is infinity. So it is in the form of infinity by infinity form. Again you write here this is, even after differentiating separately, you are getting again infinity by infinity form. So here carry the limit x tends to 0 as it is. Cot x differentiation is minus cosecant square x, and you have to differentiate the denominator, that is minus cosecant square x separately. Minus 2 cosecant x, and differentiation of cosecant x is minus cosecant x into cot x. So again carry the limit as it is. Limit x tends to 0. Here minus and gets cancelled. Cosecant square x, and you have 2 cosecant square x. So the answer becomes minus 1 by 2 cot x. So here minus 1 by 2, since minus 1 by 2 is constant, take out of the limit minus 1 by 2 into limit x tends to 0 1 by cot x. Now you have to apply the limit, right? Minus 1 by 2. Now after solving everything, you have to apply the limit. What is here? 1 by cot 0. Wherever here you have 1 by cot x. So 1 divided by, wherever you find x, you have to replace it by 0. 1 divided by cot 0. Here then it becomes minus 1 by 2. Cot 0 is infinity. So 1 by infinity is 0 into 0. Your answer is 0. Understood? Your answer is 0. So next to solve this one more problem related to this. Second problem is limit x tends to 0 log tan x to the base x. So it is not in the form of, observe this problem, limit x tends to 0 log tan x to the base x you have. Here when such a problem is given, you have to convert into the f of x by g of x form. So how do you convert here? As you all know that in logarithms, log m to the base log, as you all know that when you have a problem like log m to the base n can be written as log m to the base e divided by log n to the base e. So this rule you have to, this logarithmic rule you have to apply to this problem. So when let's write the given problem first, log tan x to the base x. So here it becomes, carry the limit x tends to 0 as it is, log tan x, apply the logarithmic rule, log tan x to the base e divided by log x to the base e. So again you confirm whether this is the which form you have. So first what you have to do here, apply the limit to the given f of x and g of x. So when you apply log tan 0 divided by log 0. So tan 0 is 0. So log 0 divided by log 0 is log 0. So it is in the form of minus infinity by minus infinity, that is infinity by infinity. Let's write here, it is in the form of infinity by infinity form. So when you have infinity by infinity form, what does the first rule of working rule of the infinity by infinity form says? You have to differentiate the numerator and denominator separately here. So carry the limit x tends to 0 as it is, differentiation of log x, that is log x, or log tan x is 1 by tan x. Tan x differentiation is secant square x. Differentiate the denominator separately. Log x differentiation is 1 by x. Again this can be simplified. Limit x tends to 0 secant square x divided by x tan x. So here, see here you have limit x tends to 0 secant square x, and see here this is, here you have in the denominator 1 by x. So it can be written as x secant square x by tan x. So wherever you find x tan x, x divided by tan x, that value limit x tends to 0, x tan x can be replaced by 1. So what you have to do is limit x tends to 0 secant square x, limit x tends to 0 secant square x, and here you can separate the limit x tends to 0 x by tan x. As you all know that limit x tends to 0 x by tan x value is 1. How this x tends to value? So when you apply the limit to this x by tan x, what you are getting? Differentiation of x, when you apply the limit to this f of x and g of x, what it becomes? 0 by tan 0 is 0. It is in the form of 0 by 0 form. So what happens? You have to differentiate the numerator separately. Differentiation of numerator is 1. Tan x differentiation is secant square x. When you apply the limit here, 1 divided by secant square 0. So here 1 by 1. So here limit x tends to 0. X by tan x value is 1. Using El Hospital rule itself, you'll get the answer as 1. So limit x tends to 0 secant square x as it is, limit x tends to 0 x by tan x value is 1. So limit x tends to 0, secant square x, the whole term value becomes 1. This is your note point, into 1. So here limit x tends to 0, secant square x can be written as cos square x. So here secant square x can be written as cos square x. So 1 by cos square x, 1 by cos square 0. 1 by cos square 0 into 1. Cos 0 value is 1. So your answer is 1 here. So next solve one more problem based on this. That is third problem. Limit x tends to 0 log x square by cot x square. So here first let's apply the limit to the function f of x and g of x. So what we will get here? Log 0 divided by cot 0. Log 0 values, as you all know, that minus infinity, cot 0 values infinity. So it is the, let's write the given function first. Limit x tends to 0 log x square by cot x square. The given function is in the form of minus infinity by infinity form. Okay, the given function is in minus infinity by infinity form. So what does the rule 1 says? You have to differentiate the numerator and denominator separately. Before that, let's carry the limit as it is. Differentiation of log x square is 1 by x square. X square differentiation is 2x. Differentiation of cot x square is minus cosecant square x square, and differentiation of this x square is 2x. See, cot x square differentiation is, as you all know, that cot x differentiation is minus cosecant square x. Cot x differentiation is minus cosecant square x. Here you have cot x square, so minus cosecant square x square, and differentiation of x square is 2x. Then here what? Here 2x, here 2x gets cancels. This numerator and denominator get cancels. Limit x tends to 0, 1 divided by x square and 1 divided by x square. This cosecant square x square can be written as 1 by sine square x square, right? So what it becomes? Limit x tends to 0, 1 by, sorry, when this sine square x square shifts to numerator, it becomes sine square x square by x square. Now let's apply the limit for this function. When you apply limit, sine square 0 by 0 square. Sine square 0 is 0, and denominator it is in the form of 0 by 0 form. 0 by 0 form rule says you have to separate differentiate the numerator and denominator separately. Limit, carry the limit like x tends to as it is. So x sine square x square. Observe this differentiation carefully. Sine square x square. So first what you have to do in the sense, first we have to treat this sine square x square as x square. X square differentiation is, sorry, here carry the minus sign as it is. So minus as it is, sine it is in the form of x square. So x square differentiation is 2x square. 2 sine x square. Then sin x differentiation is cos x. Here sin x square differentiation is cos x square. X square differentiation is 2x divided by 2x. So here 2x gets cancels. So once again I'll see here minus sin square x square. Differentiation is minus as it is sin square x square. You have to treat sin square x square as x square. X square differentiation is 2x. Here 2 as it is, x is sin x square. Sin x square differentiation is cos x square. Again here cos x differentiation is 2x. Numerator denominator differentiation x square is 2x. Limit x tends to 0. So minus 2 sin x square cos x square. When you apply limit for this problem, what do you get? Minus 2 sin 0 into cos 0 square. So minus 2 into sin 0 is 0, cos 0 is 1. So 0 into any number is 0. So your answer for this question is 0. So this problem limit extends to 0 log x square by cot square should be written in your record. The same, only third problem should be written in your record. So limit extends to 0 log x square by cot square value is 0. So here in between, in the 0 by infinity by infinity form, first you are getting infinity by infinity. In the middle of the problem you are getting 0 by 0 form.